Hi, welcome to my channel. In this video, I'm going to share my knowledge about creating range attacker with environment query system. It is the first free tutorial series in my channel. Firstly, we are going to set up basic configurations from scratch, fix animation blueprint from Paragon series, add behavior tree and AI controller, tweak parameters in environment query system. Next, range attackers are able to cast magic balls to enemies, not only targeting on player character. They can heal themselves when their health points are low. They can also jump over obstacles. In short, there are many features in this tutorial series. I hope these videos are helpful to you. Before we get into the video, I want to briefly tell you about my new released courses on Udemy. If you want to create a 2D top-down vampire-like game in Unreal Engine 5, this course is for you. In this course, you will learn pooling system to handle large number of actors, random skills, shop system with save and load framework. We will create entire leveling up system with pickable items, 2 unique bosses and 20 more mobs during the gameplay. Moreover, if you want to learn action game on mobile device, check my action game tutorial course. Your own Sekiro-like basic combat mechanism from scratch by using Unreal Engine 5. Since players' mobile specifications are quite different, mobile game developers do need to optimize lots of assets and logics, including lighting, mesh polygons, textures, tick events, etc. You can play demo right now on Googleplay without ads. The link will be in the description below. Or you can head over to my Discord to check latest coupon for the courses. Okay, let's get started. First of all, create a third-person template. I name this project to AI tutorial. Create this project. I used this free asset Paragon face. They are very useful. However, we will encounter some problems because these assets are designed mainly for Unreal Engine 4, not Unreal Engine 5 with enhanced input plugins. We will fix these problems. After importing these assets, let's open animation test map in face folder. If we try to play it, the error message shows up. As you can see, traditional input actions are no longer valid in default. So we have to delete all these relevant nodes. Instead, open Blueprint BP third person. Copy all of these nodes. Paste these nodes into face player character blueprint. Add event begin play. Hook them up. Do the same for other input actions. Copy all these 3 nodes. Compile and save. Try it again. It looks good. Set up its yaw configuration. Search YAW in Details panel. Check Use Controller Rotation Yaw. Compile and save. Tweak the height of camera boom. Change its height to 50. Decrease its target arm length to 150. I also changed its socket offset, 70 in Y direction and 30 in Z direction. Let's test it. Okay, great. Open the new level, third-person map. Uncheck its game mode override to none. We are going to drag current face player character into the level. In the Details panel, search Possess. Check Auto Possess Character to Player 0. We can control this character directly without creating new game mode. Create a new folder. Underscore tutorial. Create another folder called AI. We will add behavior tree. Right-click, select behavior tree in artificial intelligence. Rename it to BT_AI. I assume you are already familiar with behavior tree, so I don't explain the basics of this behavior tree. Create a new blackboard for this behavior tree. Name it to BB_AI. Blackboard component is storing all the information for behavior tree during the game. Create a new blueprint. Search AI controller. AI controller is used for AI character. Rename it to AIC_AI. Well, it is not convenient to dock every new window, so let's open Editor Preferences. In the Appearance tab, change Asset Open Location from Default to Main Window. Switch to Event Graph. In the AI controller, there are some special functions for this blueprint class. Click Override. Select on Possess. When this controller possesses some AI character, this event will be triggered. Call Run Behavior Tree after this event. It is a unique node in the AI controller. Select BT_AI in BT Asset pin. Compile. Drag face player character into AI folder. We will regard this copied file as AI character. Select Copy here. Rename this copied file to BP_AI. Open it. For AI character, it doesn't need these input actions, so delete them. Select BPAI self in the top left corner. It is optional to uncheck Use Controller Yaw option. Next step, search AI controller. Specify its controller to AIC_AI. Save all changes. Back to the level. Drag BPAI character into the level. Change its rotation. Spring arm and follow camera components are not necessary. Delete them too. Next, add a perception component for AI character. Switch to AI controller. Search AI perception. Add this component. In the Details panel, click plus button in Senses Config. Let's select AI Set Config. We can tweak some initial parameters. For example, basic side radius is 2000, loose side radius 2500. Actually, they are a bit smaller. We will tweak them later. Expand detection by affiliation. Check detect neutrals and detect friendlies. At the end of this series, a group of range attacker A are able to attack group B, so this AI perception component has to detect friendlies. Specify dominant sense to AI sense site. Scroll down, click on Target Perception Updated. From Stimulus pin, get function of getSense class for stimulus. Check whether its return value class is equals to AI sense site. If it is true and the perceived target has proper tag, then it is a valid target actor. Let's add a special tag for player character. Open Face Player Character Blueprint. Search Tag. Add a new tag, Player, all lowercases. Compile. So, from Actor pin in AIC_AI Blueprint, call actor has tag, type in player. Hook them up with AND node. Next, from stimulus pin, connect successfully sensed with AND node. When the percept actors meet these three requirements, this actor is qualified, which means it is valid. We need to pass this valid target actor to Blackboard for behavior tree to process next action. Call getBlackboard. From return value, call setValue as object. Setup its key name. Type make literal name. Define this literal name to target actor. T and A are uppercases. Copy this string. Open Blackboard bb_AI. Add new key. Paste this string target actor. Expand key type. Change base class from object to actor. Save all the changes. We can connect object value with actor. Well, when it is not valid, we also need to pass empty value, null value to Blackboard. So I use select node for object value. Connect AND return value with this index pin. Delete branch node. Hook them up. Connect this line actor with this true pin. Leave the false pin to empty. Compile and save. Switch to behavior tree AI. Call selector node. This node will select the first successfully executed nodes. If not, it will try to execute next node. Call sequence node under selector node. Comparing to selector node, the sequence node will only try to execute next node when current node is successfully achieved. Create a new service, name it to BTS_set_focus. Click Override. Select Receive Activation AI. This event is designed for controlling AI. Create a new Boolean variable. Name it to setFocus. We can tweak its value outside this task. In other words, we can change its value in behavior tree. Call branch node. Hook them up. From owner controller, call setFocus function. If setFocus is false, then set new focus to none. If not, pass current target actor to new focus pin. Don't forget to connect owner controller with target pin. For debugging purpose, I used getPlayerPawn node directly. I leave the comment temporary. Connect it with new focus pin. Compile. Switch to behavior tree. Add this new service. Well, I forget to set this Boolean variable to instance editable. Check it. We can see setFocus in behavior tree. Set it to true. Call another sequence node under selector node. Copy and paste this service node. For this one, uncheck setFocus. When AI detects valid target, execute sequence node in the left first. Right-click, add a decorator. Select Blackboard. Click it. I name it to set cTarget ? Set Blackboard key to target actor. Copy this decorator and paste it to this sequence node. Change its key query type to isNotSet. Select cTarget decorator again in the left. Observe aborts rule to both, which means the logics in this logic flow has higher priority. When the condition meets cTarget to true, the logic will interrupt current executing logics in not see target logics. So for player, we will see a stationary enemy will start to move immediately when enemies see player characters or members in player faction. Similarly, for debugging purpose, call wait node. If we don't add any tasks, behavior tree will not execute. Let's test it. AI sees player character. In the behavior tree, the proper logics is executed. When player character is hiding behind the wall, behavior tree also changes logics. Use debug key. Press the key apostrophe and press key number 4. Enable perception debug marker. We could clearly see when AI loses sight. End the test. Back to BTS set focus. Delete this node. Create a new variable called target actor. Change its type to blackboard key selector. Set this value to instance editable. Compile. Drag it into graph. From this variable, call get blackboard value as actor. Hook them up. Make sure in behavior tree, target actor variable in these two services are set properly. I rename this service to BTS set focus actor. Save all changes. Next, search nav mesh in place actors panel. Drag it into the level. Change its brush settings. Make sure it covers the ground of current level. Press key P to visualize covered area. AI character needs to move with EQS system. We will do it in the next lesson. See you in the next lesson.